Sean Adams. Sean, it's all yours.
Thank you very much, Cynthia. And good day, everyone. I appreciate the opportunity to be able to speak to you today on this topic. And hopefully you actually find it interesting and helpful. So very quick, just kind of quick background on AFL, so you kind of understand where we come from. So we're a global company providing optical solutions and conductor hardware. We service actually some of the key growth areas in industry today. AI-driven data center expansion, broadband deployments to close the digital divide, and the modernizing, the smartening of the electric grid, which really is the focus of today's talk. We have a strong U.S. design and manufacturing footprint, and really we're privileged to have served the U.S. electric utility space for over 40 years. So the grid stands really at an inflection point here in the United States. Utilities are faced with a vast set of challenges, and those challenges really are going to force the transformation of that grid. I think we're all aware we have an aging infrastructure. Certainly, many of us have actually felt the impacts of extreme weather events, right? $93 billion in impact from extreme weather events in 2023 alone. An interesting factor that's, kind of those things are things we've known for a while. A very interesting factor that's now emerging is load growth. For the first time in 15 years, load growth in the United States is going up. Right? There's one estimate that peak demand is expected to grow to 38 gigawatts over the next 5 years. It's going to grow by that much. Though what I'll tell you is a recent discussion that we had with one IOU just in one area saw the fact that they expect that they're going to have to double, that their load is going to double over the next 10 years. That alone would actually be 20 gigawatts increase in one region. Right, and of course we've got renewables, right? Whether that's through being driven through kind of the green movement and decarbonization, or it's actually being driven through load management to help offset challenges of the grid, as we'll talk later. Right, it's certainly a factor that is definitely impacting the grid today. And the thing is, we simply cannot build fast enough. Right? The building of transmission lines can't keep up. The chart on the left is the average queue time in months for transmission builds across the various regions. There are hundreds of projects, tens of thousands of transmission line miles that are necessary, right? And right now there is an estimated 2.6 terawatts of planned power projects seeking to connect to the U.S. grid at the end of last year. That was up 20% from the prior year, right? So you've got more than 1 terawatt of solar, more than 1 terawatt of battery storage are in the queues. Mostly those are going to be hybrid projects, followed by about 360 gigawatts of wind and 79 gigawatts of gas-fired generation. All of that is sitting there, and it's waiting on transition lines to be built. Right, and it's estimated that the congestion costs that were due to constraints in the transmission line exceeded $7.2 billion in 2021, and it's only getting worse. And we're actually throwing away energy, right? So we are actively curtailing energy, and that happens whenever when a renewable energy source, solar and wind, right? When they're either generating energy that's not necessary because the demand isn't there at the moment they're generating, all right, or they're actually generating it and it's too much for the lines to carry, you actually have to throw that power away, right? Unless you've got battery storage to put it in. And as I mentioned, battery storage and long-term battery storage is one of the key focus areas for the utility. And so we're actually losing energy. There's an estimate that for California, right? You see that chart on the left, which is actually just updated on the 18th of April from California ISO. California curtailed over 2,600 gigawatt hours of solar and wind in 2023. That's enough to power 300,000 homes. right? They've already curtailed over 1,000 in the first quarter of this year alone. And another example, Southwest Power Pool, they actually curtailed over 6,000 gigawatts of wind, and that's enough basically to power 600,000 homes, right? So you've actually got the generation. Challenge is the generation actually isn't where it's always needed. You need the transmission lines, right? But as we talked, right, there's a significantly long queue for that. So what do we do about it? Right. So to meet those challenges, the industry, right, government, there's a lot of research going in and approaches to try to really deal with this. Load management through distributed energy resources, right, that kind of decrease the demand on the transmission lines. Technologies that allow you to dynamically change what can actually be put onto the lines, right? So getting more out of the existing transmission infrastructure that's there. Being able to aggregate those distributed resources, right, into basically a virtual power plant, right, such that you can take residential and utility scale resources and bring them together to address kind of localized challenges. And of course, you have to automate the grid, right? An increase in the number of sensors and actuators, the ability to do analytics, really so we can achieve greater reliability, greater resiliency, and address the challenges that we've talked about. Right, and a lot of that means really unlocking that energy at the edge, right? Whether that's residential solar panels or community wind farms or localized battery storage, right? All of that's key. And the thing is, it's reducing energy beyond kind of just reducing energy costs, which it actually does for in residential spaces. And of course, addressing greenhouse gases. It actually provides an ability to manage the load of the grid itself, right? So utilities really are looking toward innovations that support flexible interconnect, grid automation. And as I kind of mentioned, standing up those virtual power plants, which require a lot more data to be collected, analyzed, and acted upon in real time, right? And FERC, regulations, very, very key to the utility space. FERC 2222 is really looking to push some of those options around virtual power plants and being able to kind of aggregate those distributed resources. And of course, as I mentioned, getting more out of the grid itself, right? How do you improve the performance of the infrastructure that's there? But as I said, as we know, right, very, very much regulation is key to guiding how the utilities have to address these problems. So there are moves at both a legislative level and a regulatory level to really push incentives and incentivize the utilities to improve the performance versus just kind of building new or replacing infrastructure, right? You've got FERC 881, right, that's really driving ambient adjustment ratings. Right, and that's really just taking the ambient temperature measurements, kind of combining it with data you have of the systems, right, and kind of allowing there to be an understanding of how much more power could be put onto a grid. You have an advanced version of that, dynamic line rating, right? That's going to be doing real-time monitoring of a bunch of environmental factors: temperature, wind, speed, directions, sunlight, the line conditions themselves, right? You've got moves like being able to really control how the power flows through power flow controllers and topology optimization. That it's kind of hardware and software coming together to really actually help kind of manage the flow and balance out the power when there are lines that are overstressed. So these are the challenges that really are facing the industry, right? And we're going to kind of talk about then what's the response, right? And of course, as the key title of the presentation speaks to, really, how does fiber play into that response? But what I'd like to do is actually, let's start with a survey question, right? So that should be popping up soon. What is the primary driver for your company's grid modernization investments? Is it load growth? Is it the aging infrastructure? Is it regulation? Right? Is it sustainability, or is it just something else? What's driving those investments in the modernization of the grid? So give a couple seconds for that. All right. Interesting. Great. So great input. I appreciate it. Right. So what we see is kind of an interesting spread, right? What you've got is aging infrastructure is number one. That's not surprising at all. Right. We talked about the fact of some of that infrastructure is like well past its life. And then load growth, number two, right? So that's interesting. And I think if we went back a bunch of years, that wouldn't have been the case, right? Because load growth wasn't there. But now, as you see these strong demands of data centers, onshoring of manufacturing, right? Those types of things really driving that increase in load growth. So, so very, very interesting. Okay. All right. So how do we make it all possible? Well, the thing is, to make it possible, you actually need the communication architecture to evolve, right? And it really has to go from what's been this kind of one-way communication flow to one that's very much around high bandwidth, low latency, bidirectional mesh. It's kind of turning it from that one-way small street into a significantly complex highway system, right? And so that's really what's necessary for us to be able to meet those needs, to deploy those sensors, those actuators, to be able to act upon them in real time, to really enable those things, that innovation that's necessary for the utilities to address these challenges. So fiber is actually, and its key, is future-proof. And what do I kind of mean by that? Well, what I mean by it is we actually truly haven't determined the upper limit of how much data it can carry. Really today, the limiting factor in figuring out how much data fiber can carry is the active components that are used to test it, right? And every time they kind of advance those, you find out you can actually put more down. So you're deploying a communication medium where we don't see where it runs out of bandwidth. And if you think about the fact that a majority of the spend, right, over 60% of the spend is actually in the construction of a network, not in the components, and certainly not in the fiber, right? It really pays dividends to deploy a fiber deep infrastructure. And whether that's fiber to the home or it's fiber in support of a wireless communication infrastructure such as private LTE, what it allows for is the fact that you're not sitting here 5 years down the way going, wow, I really wish I'd actually deployed a better infrastructure. Because what we do know is every day we're actually like consuming more and more data, right? Most of us, long time ago, we probably put in a fiber that had 8 fibers, and you wondered, why will I ever need any more, right? And today we talk about fibers on the order, not yet in the grid, but in other spaces. And that AI data center space I talked about, where we're talking about cables that actually have over 3,000 fibers in them, one cable. So a key thing that we actually see fiber bring and an optical infrastructure brings as part of your communication solution is really this establishment of what we like to think of as a safer network. And what that stands for is a network that is sustainable, right? And sustainability was number 3 on the list of what's driving grid modernization. Accessible, flexible, expandable, and reliable, right? And certainly in the electric utility space, right, the number one mandate for a utility, what utilities think about when they wake up in the morning is how do they actually make sure they deliver reliable energy, right? Because it is really, truly the most important part of the infrastructure the United States has. And making sure to design solutions that are accessible. That means you can easily access them. You can go back into them. You can expand upon them. That they are flexible. That your solution that you deploy, that the fiber network you deploy, whether it's the optical cable and the optical connectivity, allows you to be flexible with your architectures, and that it's expandable, right? That you can build upon it. That what you put in today, you can expand upon in the future in a cost-effective way. That's all absolutely key, and what the industry really needs to think about. When I say the industry, I mean kind of we as manufacturers need to think about of how we innovate. So let's actually kind of walk through really some of the innovations that are there and some of the solutions that are there to really support the utilities. So, community, the foundation of the communication infrastructure for utilities actually has always been on optics, or at least for the last 40 years has been on optics. And it's around the fact of the optical ground wire that actually goes through our transmission grid, right? And so that's been happening, as I said, over 40 years, and AFL is actually proud to have serviced that space throughout that entire time, right? But to meet the needs that are there today, right, the growing demand for transmission lines, the challenges in right-of-ways, we've actually had to keep up as well, right? We have to be making moves that are leading to things where we're providing smaller, lighter, higher fiber count solutions that enable utilities to be more effective in the usage of their money. So you can now fit, you look on the left-hand side, right, in the exact same outer diameter that used to be for 96 fiber, you can actually fit 144 fiber. Right, and if you kind of compare 96 fiber, what you see is there's been over a 10% reduction, right, in the outer diameter for 96 fiber OPGW from kind of what has been traditional to what we'd say today is modern, right? And the industry is supplying cables that actually have significantly more fiber in the OPGW, up to 432 fibers today. And by the way, that's not limited by the amount of fiber you can put in. That's more limited by what the industry is interested in putting in. We can go higher than that, right? So it's really all around meeting the industry's needs. So let's have another poll question, right? What is the OPGW fiber count you are looking to deploy to support your network needs? Is it 144 fibers? Is it 288? Is it 432? Do you see need for greater than 432 as you think about kind of where the grid's going and the challenges that you have? So we'll give a minute or so for folks to give their inputs on this one as well. So overwhelming majority, 144 fiber, that's not surprising, right? That's kind of been very much the norm. There's actually even some states, as maybe some of you are aware, that actually limits the utilities to actually only deploying that much fiber. Very, very interesting that there are some, right? It's a small percentage, but it's some that are actually looking to deploy greater than 432, right? And as we think about certain applications that are enabled by actually deploying that higher fiber count, potentially that will actually continue to shift over time. So thank you for the responses on those. All right. So here's the thing. Optical fiber cable actually isn't all that interesting when it stands on its own. It really actually takes a solution ecosystem. And the industry is very much focused there, right? And as we talk further through this, we have to innovate in all of these areas. So you certainly need a strong portfolio of conductor hardware that's able to address, suspension, mounting, vibration management of the cables. That's absolutely key. It's part of the solution of deploying OPGW into the grid. And you need optical connectivity, right? You need to be able to, again, a cable without actually being able to connect into it isn't all that interesting. So you need the optical connectivity, and then you actually also need optical test equipment, right? You have to be able to verify and validate that the deployment was a good one. So for any of these, as we think about it's not a product that is actually coming to the industry. We actually have to think about it as a solution that's coming to the industry. And the advancements we do in one space, let's say by kind of improving the overall outer diameter of OPGW, has to go hand in hand with advancements that occur in all of these spaces. And the industry very much has focused on doing that. And when you kind of think about the fact of, where a fiber network is available, it is the preferred communication to enable grid automation, right? It's if you've got fiber there, it really is the one you want to go use, right? Always a bit of a challenge to kind of understand the fact of, should I deploy a fiber network if it isn't always there, right? But as we talked about, it being that future-proof medium, right? And the challenges that are being faced and the advancements that are being made really actually does kind of drive fibers being a key solution piece to that. And you can very much actually think about the fact there's kind of this analogous between the power network, right, and a kind of a fiber to the home network, right? So if you kind of look at the picture we've got here, you know, on the top, you've got generation on the far left-hand side and the subscriber on the right. As you think about a telecommunication network, you've got an internet service provider on the far left and a subscriber on the right. And as you step down through them, what you really have is kind of a one-to-one relationship between kind of the key points in those two networks. And that's why actually very much kind of deploying a fiber network within the grid, right, really makes sense, right? Because there is this one-to-one relationship and there are solutions all the way along the line, right, that allow you to make use of the infrastructure you have. Right. And technology is really great, but only if it actually solves the problem. So the solutions we come up with really have to be designed to allow a utility to be the most efficient in using their existing infrastructure. Right. So how do we really do that? And so the industry has developed solutions that are both for aerial and underground deployments. Right. And it's all with very much of a focus of reducing the size, reducing the deployment complexity, easing the permitting challenges, right? So on the left-hand side, you see the aerial right away. And here you can actually think of that in really two ways. There's the supply zone, the power zone, right? And there the industry has developed ADSS, and we'll touch on that cable, that lets you actually deploy the optical infrastructure up in the supply zone, right? In the space that's truly owned by the utilities. And then, of course, there's a communication zone that's there. And there you could do ADSS, but you could also do loose tube, and you can do what we refer to as modern flexible ribbon that I'll talk about more, right? So you kind of get this opportunity to use those spaces. And in the underground right away, you have a number of options, right? There's blown solutions, there's duct, there's direct buried. And again, there's actually been advancements there in optical cable infrastructure, optical cable designs, to really make the best use of that. We'll touch on a few of the major ones that are enablers as we kind of move into as we kind of really work to help the utilities be more effective. So let's start with ADSS, right? That's all dielectric self-supporting. This unlocks the supply zone. And what does that mean? Well, it means greater pole flexibility. It means easier permitting, and permitting is really one of the #1 challenges that are listed out there for why it's hard to build out a network, whether that's a power grid or a telecommunication network, right? And it reduces overall installation costs. And the real way to think about ADSS, right, and an infrastructure based on it, is it's all about total cost of ownership savings. That's both on day one, because you're reducing the make-ready costs, you're easing permitting, right? But it's also kind of day through multiple decades. Why? Because ADSS is more reliable. Right? It's designed to meet the challenges of ice and wind, right? You don't have, all of us have driven down the street where you look at a messenger wire that has fiber wrapped around it. That's normally how you deploy it in the comm space, right? And you see the messenger wire with little metal strands sticking out. Why? Because it breaks down. So you got to go back and you got to repair it, right? ADSS doesn't have that. So it's very much about cost of ownership play, right? And again, here you have to think about an ecosystem. You need the conductor hardware to be able to mount that successfully, whether, single and dual trunnions, suspension units, dead ends, right? And you need the optical connectivity, aerial splice enclosures, terminals, field installable connectors. Those are all pieces that kind of enable the solution. There's also been advancements in what's called microcable. And what microcable really is, it's kind of everything you always loved about traditional loose tube, except for it's got a step function improvement in density, right? So they're smaller, they're lighter. It's all around really driving down that size, and they're perfect for underground air-blown applications. And here, the industry also has made advancements in duct technology, right? Kind of reducing that overall footprint, right? Again, it's an ecosystem. You've got to solve it at every single step. And so these microducts really actually ease kind of the deployment and the permitting challenges that are faced by utilities. And so you can kind of see along there in the picture, you kind of look at that traditional 144 fiber loose tube on the far left, right? And then you actually see the other 144 fiber versions that could be there, whether it's heavy duty microcable, right? Or it's all the way down to 200 micron based fiber outside plant microcable. And as we saw from the survey, right, 144 is kind of that sweet spot, right? You're looking to deploy in, right? So it significantly reduces that size. That actually says that you have it's easier to deploy, and you also have a chance that in the future, if you need more, you might actually still have space in your microducts to do that. And then actually you've got what is truly a transformative innovation, which is what we often refer to as modern flexible ribbon. And this is ribbon that allows you can actually work with it. It's gel free, so you can work with it as a ribbon or actually as a single fiber, because you can just pull one of those fibers out and work with it. So from being able to use it and interface with it, it kind of really addresses the kind of the AFE in the safer that we talked about. But it also has significantly reduced the overall footprint. So you can see in that top picture, right, kind of your standard 432 fiber loose tube, right? Its outer diameter was about 21 millimeters, right? That can be brought down to 13.5 millimeters with modern flexible ribbon. And as I mentioned before, right, kind of the key solution that's being used in those AI data center spaces is the 3456 fiber cable. That's 30 millimeters, 3,456 fibers in a 30 millimeter diameter jacket. That's unbelievable. That is truly transformational when you're looking to deploy, whether it's a lot of fiber or even smaller fiber count, but you don't have the space, right? You don't, you need to be able to fit something just a little bit more through the duct that you already have. That's what this allows you to do. The other thing is, because you can now engage with it, you can do what's called mass fusion splicing, right? There are splicers that are ribbon splicers. You get an 80% throughput in splicing, because you can actually splice 12 fibers at a time. And so it significantly reduces part of one of the more complex things in the deployment of fiber, which is that splicing. So it really allows for, again, if you think about the fact that 60% of the cost is construction, this really allows for kind of overbuilding of the network without significantly impacting the cost and not placing increased burden on the infrastructure itself. But as we've kind of chatted, that's all great, but not if you don't actually have the ecosystem around it. And so here the industry, the manufacturers are very much focused on improvements in the connectivity space that enable that density and enable that ease of deployment, again, to really let the utilities make the most effective use, right, of their infrastructure today, whether that's in existing underground vaults or space in the poles, right? So it's so key there that the innovation happens. And it's very, very important, right? If you think about kind of what does optical connectivity, actually do? Like, what's a splice enclosure? What's kind of what you see there on the right-hand side? What does it do? Well, it's there to actually, protect those critical network splices and the cable components. It's key to your reliability, right? So these are tested to the highest of standards, right? The Telcordia spec GR771, right, is a very stringent standard. That optical enclosure you see there, and optical enclosures that actually come from reputable companies that make these, right? Those actually go through a set of testing where that is submerged for 7 days under 20 feet of water to make sure there's no water ingress. Right now, a challenge is that some of the products that are coming from non-US suppliers in these standards, they're not being met. So that's really why you want to make sure that when you're actually picking the components that go into your network, make sure they're actually coming from companies that are truly doing the testing, can give you those test results, right? Because Reliability is paramount, right? You need to make sure you're working with the highest quality supplier, right? When you're addressing these things for any of the components you're putting into the network. And here again, right, that focus is on how do you reduce that overall footprint? Because if you make it smaller, you can fit it into what's already there. You can fit it in easier. If you actually have to do something new, you don't have to take up as much space. So like with cables, kind of reducing that connectivity footprint is key, right? And so manufacturers are very, very much focused on maximizing the use of the existing infrastructure, reducing the permitting and siting challenges, reducing deployment time and skill level, right? And driving strong quality reliability. And this all brings you back to kind of what we talked about, where you very much want to think about the network that you're deploying as one that's safer, right? Sustainable, accessible, expandable, and reliable, right? Those are kind of key things to keep in mind as you're designing your network and building it out. And when new installations actually are required, because they are, there's innovations that have actually happened here as well. Who would actually think that you could innovate in handholds? But the industry has. So a new handhold option that's out there is what we refer to really as kind of these modern collapsible handholds that actually meet the strict standards of the concrete handholds, but they're much lighter and they're much more compact. So like you're able to ship 200 of these in the exact same truck where you only would have been able to ship maybe 50 to 80 before, right? So you're right there saving money, saving time. It's better for the environment. But what's also very, very powerful for here, and you can kind of see the picture that's on the right-hand side. You can actually put 4 or 5 of these in the back of a flatbed, right? And you can do a 2-person install. So where before you're going to have to be bringing out maybe 1 concrete one on that, or actually probably a much bigger truck carrying them out. You're going to actually need to have a backhoe that was going to be able to lift it off and help put it in. You're now actually able to do that with just 2 people and a flatbed truck. That actually allows some of your more expensive, items in the field, like a backhoe, off doing what it should be doing, which is digging the next hole, right? So these are innovations, again, of how do you actually help make these deployments more effective? How do you enable the workforce that you have to be more effective? And these are actually designed, these collapsible handholds, they're designed to the strict standards, right? Tier 15, tier 22. So tier 15, right? That's a 15,000 pound design load. It's actually tested, by the way, to 22,500 pounds. And the tier 22 is a 22.5K pound design load. It's actually tested at 33,750 pounds of tested load, right? So these things are perfectly designed to design for kind of driveway, parking lot, off-roadway applications, right? And again, designed for the situations where you're building out new, you can do it effectively, quickly, and make the best use of your investments. And so it really kind of brings the fact that you bring all these innovations together, and you have to innovate in all of them: fiber, connectivity, handholds, and all of that focus of reducing the footprint in the field, making use of both the aerial and the underground opportunities that are there, and really enabling utilities to make the use of their existing infrastructure or their new investments, right? So smaller handholds, that means you've got more options in network design and construction, right? So you're reducing your siting and your permitting challenges. Smaller ducts and cable diameter, that means lower boring costs. That means you can make use of duct that's already installed. The flexible ribbon technology we talked about provides lower weight loading on the messenger lines, right? It enhances space savings on the poles and the messengers themselves, and it reduces overall make-ready costs. And then ADSS, which we kind of started with, right, really actually provides the utilities that opportunity to unlock the supply zone for deployments. And that significantly reduces make-ready costs and permitting challenges. As we talked about there, it's very much of a cost of ownership win. And when you bring these all together, right, the modern flexible ribbon, the modern optical enclosures that are designed for that density, and density doesn't always mean a lot more fiber. What it means is fitting things in a tighter space and bringing them together into smaller handles, right? You're able to reduce the overall footprint and therefore challenge that you have. And all of this is actually done while addressing kind of really the number one goal of a utility, which is reliability. So one more, this is our very last survey. Are you planning to deploy fiber beyond the substation into your distribution grid to support grid automation? That could be no. It could be yes, but only in very, very special circumstances. Could be yes, but only in support of a wireless LTE network. Or it could be yes, fiber all the way to the meter. So very interested in how the utility thinks, the industry thinks of this. So we'll give a minute. All right. Few saying no. Yep. We've got I think it's majority is yes. They're kind of seeing fiber going deeper into it, but mainly those are going to be in very, very special circumstances, right? Or in support of that private LTE network. That's making up over 75%. And that that kind of really does make sense, right? As you kind of think about what's going into the grid, how do you best kind of connect with those? Not surprised at all by the results in this poll. So that's great. Thank you. All right. And the thing to keep in mind is, fiber is an optical infrastructure, whether it's fiber all the way to a device or fiber to enable a private LTE solution that then can actually connect to those devices, is key to the modernization of the grid. It also is that future-proof enabler to opportunity for a utility to really actually provide greater levels of applications and services to their customers and their communities, right? And potentially actually make more profit for their stakeholders. So there's kind of a number of different applications, right? And this is only a small set that you think about of kind of what can fiber enable. Well, certainly I think we all would understand that it enables high-speed broadband. And the electric cooperatives, right, for almost the past decade have really been leading the charge here in closing the digital divide with fiber to the home solutions, right? They really, as I was just actually down in Washington, D.C. for what's called Fiber Day on the Hill, where we kind of explained to Congress the benefits of fiber, right? And one of the key things I pointed out there is the electric cooperatives have been actually solving the digital divide long before Washington thought it was interesting, right? And so there, the electric utilities, the cooperatives specifically, have really been at the forefront, right? But there are other applications that get unlocked. Recently, Ericsson and NRTC actually did a pilot with West Kentucky Rural Electric, and it was a fiber-enabled private LTE network. And two of the use cases they specifically talked about, along with the ones we've talked about here, kind of supporting SCADA and supporting kind of connection and the modernization of the grid. Two of the applications they talked about was one, enabling smart agriculture, right? Lots of farming that's out there, right? But those farmers they don't actually have the connectivity to truly transform their farms into a smart agriculture solution, right? By combining this fiber deep private LTE network, that's one of the applications that gets unlocked. And there you're helping the community and you're very much actually, you're servicing the country overall. Another one was first responder network, right? By allowing the first responders to make use of spectrum, that part of the spectrum that's there for the private LTE, right, was another application that was talked about. So now, again, you're making these investments are actually helping the community that the grid is in, right? And then you actually have middle mile broadband. And actually, there were a number of utilities that recently won part of the Middle Mile Award from the Department of Commerce's Middle Mile funding that came out of the infrastructure bill, right? You kind of saw utilities names there standing alongside of your typical service providers, right? So that's another way, right? Because the transmission grid is a perfect natural pathway for that middle mile. And this actually has been a key space where the utilities have been kind of helping bridge the divide. You might actually have areas that would really love to have fiber to the home, potentially a fiber to the home that's deployed by, let's say, electric cooperative, but they actually have to be able to get the internet from somewhere. And that's where the middle mile build out very, very much helps. So these are all kind of key areas where you think about that kind of fiber as being that future-proof enabler, right? It can enable more than just the modernizing of the grid. It can really actually enable the modernizing of the community that the grid is within. And so to kind of close it out, really, for us, AFL is very much how can we help? How can we actually help you enable a smarter grid? Whether that's underground builds, right, for kind of laterals and feeders, whether it's grid hardening, kind of pole and conductor replacement, grid automation, microgrids. We really actually have focused on kind of optical cable connectivity solutions around that ease of deployment, the reliability, the fact you can trust the testing, you can trust the products, and then coupling that with conductor accessories and OPGW and ADSS. There really are cables that are designed specifically for the electric utilities. And so we're certainly here to work with you and help you. As there are a number of players in the industry that really are looking to try to help. What is kind of one of the most important things as we kind of enter the back end of this decade is truly addressing those challenges that we started with and kind of maintaining what's often referred to as the largest machine in the world, right, which is the US electric grid. So with that, that's our last slide, and I really appreciate the time. And if there's any specific questions that already haven't been answered by my partner in crime, Austin, who's been on, I'd be happy to take them.
I don't see any other questions coming in. I'll give you a few more minutes to submit your questions. I guess that's it, Sean.
Okay.
Thank you so much. Just
Thank you.
another reminder that the presentation slides and recording will be available in networks within a week. Once again, I thank Sean and AFL for this presentation, and thank you all for attending.
Thank you.
Have a great day.
Have a great day. Bye-bye.